Ryan, hi.
Olo.
Olo, YOLO, solo.
Vending machine.
See, that only makes sense if I uploaded y'all's from yesterday. I think I did. Okay, so good morning, welcome back. Fourth period. We're going to warm up by evaluating our logarithmic functions today. Bless you. All right, so we left these two blank. So let's just knock these out really quick, but I want to make one change that'll lead into what we're doing today. So I do have to do the equal something, but instead of writing x, which is what you guys got used to, I'm going to change it to y. Cosmetic change, that's all it is. Okay, relax, calm down. Everything's exactly the same. I've just got a different variable now. Okay. What's my base?
7.
What's the exponent?
Y.
And what's the result?
343.
Beautiful. And you're thinking, how many times does 7 divide 343? 3 times. Because 343 divided by 7 is 49. 49 divided by 7 is 7. And 7 divided by 7 is 1. I had to divide it 3 times before I hit the 1. Okay? So y is 3. Good. Looking at this one. What's my base?
5.
My exponent?
Y.
And my results?
625.
Beautiful. And y equals?
3.
3?
No.
4.
4. 4 times 4. 5 times 5 is 25. 25 times 5 is
125.
125. And then 125 times 5. 625. Okay,
Yeah.
so it's 4. All right, you guys are feeling really comfortable with this. I'm super, super happy. Flip the page. Because now that we can do all that, we can graph. Can I slide this? This paper's up. Okay. All right, I do need to edit some typos on this table of values. I'm sorry. Change this to 1 over 10. Change this to 10. Change this to 100. So now what we're doing here is this x here is going in here. And then f of x is going to be taking the place of our y. All right. Fraction. I'm going to leave it for later. I'm going to deal with 0 first. Log base 10 of 0. That one's weird. I'm going to skip it. Log base 10 of 1. That's our shortcut.
Clarity 10. I do not know. Don't say that.
0.
You're not wrong. Anything times 1 is itself, but we're talking exponent. How many times do I have to multiply 10 to itself to get 1? No times. Don't multiply 10 to itself. It's just 0. This is our shortcut. All right, the next one. Log base 10 of 10. Another shortcut.
1.
It's 1 because I have a match between the base of the logarithm and the thing I'm taking the logarithm of.
So if they match.
They match, it's 1. Log base 10 of 100. 2, because 10 times 10 is 100, and I'm multiplying 10 to itself 2 times. Okay? All right, let's go back toward that 1/10, okay? Just because that 0 sitting there is kind of freaking me out. All right, so I have log base 10 of 1/10. And I'm writing on line paper just so I have a bit more room, okay? If I follow my process from yesterday, that equals y. Then I have 10 to the y equals 1/10. I'm going from whole number base to fraction base. That means that my exponent is a negative. I'm going once again from whole number base with the exponent to a fractional answer. My exponent has to be negative to make that happen. Okay? Now compare this base to the denominator. How many times do I have to multiply 10 to itself to get 10? 1. Negative 1.
So it's negative 1.
It is. So log base 10 of 1/10 is negative 1. Now I'm stuck talking about this log base 10 of 0. Okay. We need to find how many times we multiply 10 to itself to give us 0. All right, if I take 10 to the 0, it's 1. Because anything to the 0 power is 1. I just discovered that 10 to the negative 1 is 1/10. Okay? What if I make this more negative?
Negative 10.
Negative 10. All right, so this is, remember how we handle negative exponent. Take the base, write it as its reciprocal. Take the exponent, bless you, write it as a positive. So now I have 1/10 to the 10. That's the same as 1/10 times 1/10 times 1/10 times 1/10 times a whole bunch of times. If I were to multiply all the ones together, I would get
1.
1, because 1 times 1 is 1 times 1 is 1 times 1 is. And now I have all these 10s. I'm going to have 10 of them.
No,
10,000.
yeah.
Okay, if I write 10,000,
Because 10 times 10 is 100. 100 times 10 is 1,000.
Okay.
10 is
10 times 10 is 100. 10 times 10 times 10 is 1,000. 10 times 10 times 10 times 10 is 10,000. Do you see the pattern on the zeros?
You're just adding, yeah,
You're just adding a zero
another
for each
zero.
one.
Exactly, which means how many zeros am I supposed to have over here?
10.
10 of them. Okay, pretend I've written all 10. I haven't, but pretend I have.
You did 10.
We're pretending. Have I written 0? No. Because I have a numerator of 1. There's one piece out of all of these others. Can I multiply 10 to itself down here in such a way that this thing actually becomes 0? So there isn't a number that I can write that makes that happen. Reasons. Yes, to create the mind-blown emoji. That's all this is. Okay, so I want you to come back to your notes from yesterday real quick, under your properties, and I want you to add one more shortcut. The log any base of 0 shall now forever, henceforth, be undefined. Forever and ever and always. All right? All right. So, undefined. We have a full table of values. We can start to try to graph the thing. All right. We're going to start with the first point. Our first point is x equals 1/10. Now, if I look at the scale of what I've already provided, it looks like every 2 tick marks is a whole number. There we go. Which means every tick mark is 0.5 and 1/10 is 0.1, and so it's like right about there. And when x is 1/10, y is -1, so it's like right about there. Really close to 0, but not quite. When x is 0, it's undefined. Okay, so for undefined, I'm going to draw myself a wall that says Do not pass. Okay. X is 1, y is 0. X is 10, y is 1. X is 100.
We can't go that far.
I can't go that far, so I'm going to stop.
So that's it.
That's
Wait,
it. That's
so
all I can graph on this
Where's,
one.
this is the one?
Mm-hmm.
1, 0.
All right, now I'm going to draw it. So from here to here, I can draw it pretty nice. And from here to here, I can draw it pretty nice. And then after that, I'm going to continue going more and closer to the asymptote in the x direction as I continue getting closer and closer to the negative infinity in the y. So it's going to be like, don't actually touch the axis. Get really darn close, but don't touch it. Okay? Because that's what an asymptote means. No one likes touching the asymptotes. And this is the function f of x equals log base 10 of x. Let me take a little detour. How many fingers we got? How many toes we got?
10.
How do we count?
Wait, I'm counting.
By one.
0, 1, 2, 3, 4, 5, 6, 7, 8, 9. And if I'm going to write 10, I can't do it in a single digit anymore. I have to write 1, 0 for 10. This number is now my counting. I started over. So my next number is 1, 1. 10 and 1, 11. 10 and 2, 12. 10 and 3, 13. 10 and 4, 14. 10 and 5, 15. In Spanish, 10 y 6, 10 and 6. 10 y 7, 10 and 7. 10 y 8, 10 and 8. 10 y 9, 10 and 9. And the next number after that is? I'm now incrementing up on that 10's place value. Okay? You're like, why are you telling me this? We discovered this in like first grade. If I keep going and I get 9, 9, the next number after that is
10 and 0.
1, 0, 0. 100. Wait, ready to blow your minds? This place value is the same as your 10 to the zeros. This place value is the same as your 10 to the first power. This place value is the same as your 10 to the second power. Okay? Now, I take this little side detour and I chat with you about it because it makes writing this logarithm, like the name of it, it gives us a shortcut. I can write this logarithm and say this logarithm as just log of x. I don't need to say the base because we are so comfortable in counting and thinking in powers of 10 in base 10 that this logarithm, we can assume the 10. Your homework assignment practice for today and this weekend will not have base 10s listed. It'll just have log of stuff. Okay? So if you see just log of stuff, we mean log base 10 of stuff. Okay? Yes? Okay. All right, let's look at the dashed dotted yellow line that I drew, our wall. What does that thing look like? I'm getting closer and closer to it, but I'm not touching it. It's an asymptote. What kind? Horizontal or vertical?
Vertical.
Vertical. Which we now shall henceforth write as VA You may see that on your assignment. Excuse me, something in my throat. PCVA, reading vertical asymptote. Function? Yes or no?
I remember.
Wait, Miss, can you go ahead?
I heard yes, this thing is a function. Yes, you're right, because it passes the vertical line test. If I grabbed a vertical line and threw it over, yes, I know here it's not going to look like it passes. But if I were to zoom in sufficiently close, I would see that that continues to curve to the side, to the left, more and more. What's my domain?
Or numbers.
Would it
All
be
real numbers.
all real numbers?
Can I reach 0?
Oh, no.
X greater than 0.
Yeah. I can't reach 0, which means if I can't reach 0, I also can't reach the negatives. I'm stuck on the positive side. And that means that x will always be some value that is bigger than 0, even if it's only bigger than 0 by a tiny little bit. What's my range? This one's all real numbers. You can see very clearly going down here towards negative infinity, it's getting there really fast. And on this side, it looks like it flattens out. But I could put a really big power on 10, couldn't I? I could do 10 to the million. That would be a 1 with a million zeros after it, and that would be really long to write. So I'm going to shortcut it and just write 10 to the million. I could if I wanted to. I don't want to. That's crazy. But I could put it there, which means I could end up way up there in the y's. It's going to take a long time. But I can do it. This kind of function is called a logarithmic growth. Because we are growing as we move from left to right, and there's no limit to how big we can get this thing. We're just going to take a very long time to get there.
Can we just put log growth?
Great question.
Anaïs is going home.
Thank you. I'd be okay with it if you just write log growth. I would love to have the whole thing written out logarithmic as that practice. And it's pronounced like log, like you cut down a tree and have a log. And then like rhythm, like you're drumming on it. Logarithmic. That's how it's pronounced. Okay, let's graph some of these things. Because if you notice, I very quickly stopped giving you values of x. And so I want to show you some tips and tricks so that you can find some really good values of x to make this graphing go fast for you. Okay? All right, let's look at this first one. Let's look at the first two. I'm going to read the functions, and I want you to listen closely as to where I'm putting the pauses and try to guess what you think that means for how we're calculating this thing.
Pausing?
I'm going to pause as I read it. Okay? Listen. Yeah, listen. Ready? Log base 10 of x plus 3.
Pause.
I paused. What do you think is happening
The
first?
X is 3. No.
What do you think is happening first? Log base 10 of x
You're doing the x plus 3 first.
plus 3. There's a huge pause between the x and the 3.
So you
Oh.
do
First
all
you
the
figure
stuff,
out the
and
log
then at
x,
the end you add
log
three.
10.
Yeah, I'm going to figure out the log x part first, and when I'm done, I'm going to add 3 to it. Listen to this one. Log base 10 of x minus 5.
First you do the x minus 5.
I'm going to figure out the x minus 5 first, and then grab the log base 10 of that value. All right, let's do this. I'm going to do it in blue. I want to color this one in blue. Okay. Log base 10 of 0 plus 3.
Oh, so was I right?
How do you mean?
I said the X is 3.
The x is 0.
Never mind.
Yeah.
I'm not right.
It's okay. I love that you're guessing for it. Like that's half of math is guess and then try to figure out what we did. All right, let's calculate log base 10 of 0. Our new shortcut said log base anything of 0 is
Is
Oh,
One.
defined.
undefined.
oh, a loading thought.
It's okay. It's all right. You were testing me.
I was, man.
You were, and so this is undefined. So I have undefined plus 3.
3. Oh, no.
But it's undefined.
Undefined.
Sorry.
How am I supposed to add 3 to undefined?
So it's undefined.
I can't, so it stays undefined.
Undefined times tree.
It's still undefined, man. All right.
I thought, because like that, how it was written out, Jeffrey, 10 to the 0, I thought it would have been into 1 and then plus 3.
Oh, because this isn't an exponent on 10. Yeah. Okay. Log base 10 of 1 plus 3.
That is 4.
How did you get 4?
1 plus 3 is
3
4.
is 4.
Okay, but we can't add the 1 and the 3 together yet. We've got to resolve the 1 with the
Zero.
log.
Hold on, let me get the calculator.
Log base anything of 1 is
0.
Oh.
Equals 0 and then 0 plus
It's 3.
is 3.
Do you see it? I'm highlighting what we've got to resolve first. Do you see it? Okay, I can't do that plus 3 until I'm done with the log. Okay, log base 10 of 10, resolve that first,
100.
and then plus 3.
103.
Wait, didn't you say something about that?
Wait, miss.
About our exponent and the
Wait,
difference?
It's 13. No,
There's a match here. If they are matching, it is 1, and 1 plus 3 is indeed 4.
4.
Yeah, I remember.
See, man,
did.
drunk faces.
All right, we have enough information to start our graph. Where is the undefined location?
And the SM.
0.
At x is 0, so there's our vertical asymptote, which is exactly what you were about to say.
Okay, I was like, I was uncertain of if I was gonna say it right.
You were going to say it right.
Don't stop.
That's all right. So at x equals 0, I have to throw a vertical asymptote on there. And now I can graph the other things. At x is 1, y is 3. Please notice that these graphs are counting by halves. That means every 2 lines is a whole number. When x is 10, y is 4. 1, 2, 3, 4.
So,
Hey, did I?
Now I can connect these two, and because I know this is a logarithm, I know that on this side I'm going to approach the asymptote, and I'm just going to draw it as long as I can. Oh, before I feel like I'm going to crash. And then this side's going to shoot off this way.
All the way to 2.
This is my function f of x, which is the log base 10 of x plus 3. Compare the blue one to the yellow one.
It's longer.
It
It's,
does. If I were
Horizontal
to
compression.
if I were to sketch, I love all these words. If I were to sketch the yellow one on the same graph, I would have something that looks like this.
Horizontal.
It's moved.
It's moved.
Oh, it's shifted
It shifted, it translated up
by a lot of units.
It
by some
grew.
units.
It has had growth.
How many
I'm gonna watch this video.
how many units up did I go?
3.
4.
For which one?
No, yeah, that's 3.
The yellow one, this one? I just copied this.
You pretty much shifted.
Yeah, I just
up.
copied.
So
It
when
looks like I slid up 3 units. Look at this.
you had 3 growth.
Look at this, look at this.
mm-hmm.
Suspicious. Okay, let's do this one.
My guess is moved down 5.
Okay, he's guessing down 5. Let's actually work out the numbers. Let's give it a sketch. Let's see where it ends up. All right, so this is going to be log base 10 of 5 minus 5. I need to resolve the 5 minus 5 first.
It's 0.
It's 0, so this is log base 10 of 0, but
Undefined. Oh,
yeah, you're right, but log base 10 of 0 is undefined. I have a vertical asymptote right at that location. The next points. Log base 10 of 6 plus 5. have to resolve the 6 minus 5 first.
Uno.
Uno. Log base 10 of 1 is
1.
0.
0. Log base
Oh.
anything of 1 is 0. The next one, log base 10 of 15 minus 5. Resolve the 15 minus 5 first.
That's, I was going to say 5. That's 10.
That's
It's
1.
10. Log base 10 of 10 is,
1.
because I have a match. I have enough to graph this. I have a vertical asymptote at x equals 5. When x is 6, y is 0. When x is 15, y is 1.
Wait, this.
Yeah?
Where did we get that yellow line from?
That yellow one was me copying the one above.
Oh,
I just
okay.
copied this down here.
So wait.
I'll label it for you. I'll label it for you. Okay. And then this was log base 10 of x plus 3. And then this is log base 10 of x minus 5. Is that okay? Is that better? Yes? Okay. So between the yellow, which I'm going to air parentheses call our parent function, it's not really parent function, okay? Logarithms and exponentials don't have strict parent functions like all the others. But if I were to think of my yellow log base 10 of x as a parent, what happened between the original yellow function and the pink one that was log base 10 of x minus 5?
Horizontal shift.
It looks like it was a horizontal shift. In which direction?
Right.
To the right.
The east direction.
To the east direction.
Progression of east motion.
Suspicious?
That's just suspicious.
I'm going to end this here. And this is spoilers for the next several days worth of stuff that we do. That's it. Thanks, guys.
Bye.
Bye.